Okay, so I was talking about or finishing up this example, and I just wanted to quickly kind of compare these two intensities that we just looked at. So we said that there was the average intensity of sunlight on Earth's surface is about 700 watts per meter squared. Okay. And we just calculated the amount of energy that would be on some solar panel. And then we calculated the intensity that the sunlight would have if it's concentrated by a magnifying glass on an area that's much smaller than its own. Okay. And so we did that and we found this intensity of 1.4 times 10 to the 5th watts per meter squared. Now compare that with the intensity that usually just goes on the Earth's surface. That's just 700 watts per meters, okay, a meter squared. So just kind of take that into consideration, or just understand that that's why when you have a magnifying glass and light comes through it, that you can technically create fire, okay, and that is because the intensity is highly concentrated. Okay, so I have one more example, and that is 16.10. Okay, and we are looking at two identical waves that each have an intensity of 1 watt per meter squared. They interfere perfectly constructively, and we want to know the intensity of that resulting wave. Okay, so remember that intensity is equal to power over area, okay? And when we're looking at a constructive interference, okay, let's go back and remember that when we have constructive interference, our resultant of these two waves add up perfectly, okay? And our amplitude is now 2 times the original amplitude. Okay, so our waves that are exactly identical with amplitudes x, when they come together, their amplitudes go to 2x because they add together. Okay, so when we want to know our intensity of this resulting wave, we need to take that into consideration, that our amplitude x now is 2x. Okay, so this is initial and this is our final. You can think of it that way. So it was first, our amplitude was just x, and now it is 2 times that amplitude. Okay, now we need to relate this somehow to intensity and relate, so we need to relate our intensity to our amplitude somehow. Remember, this is area, this is not amplitude, okay? We can note that intensity equals our power, and remember our power we just looked at is some energy over time. Okay, so let's go ahead and look at this for a second. We know that time is just time, area is just area, so then what is energy like here? So if we go back a little ways, energy in these waveforms is going to be 1/2 kx squared. Okay, so 1/2 k times our amplitude squared. Okay, so that's our energy. Sorry, my dog's barking. So our energy is then going to be proportional to our amplitude squared. Okay, this also means that our intensity is proportional to amplitude squared. Okay, so intensity is proportional to energy, which is proportional to our amplitude squared. And so in our first case, I is going to be just proportional to our amplitude squared. But then after they interfere, it's going to be proportional to 2 times that amplitude. And again, this is squared. Okay? So this means it should be 4 times my amplitude squared. Okay? So then when we have these 2 identical waves with intensities of 1 watt per meter squared, okay, what is our intensity of the resulting wave? Okay, well, if we look at these 2 intensities, I know I'm saying intensities a lot, but bear with me. When we're looking at them, we can see that this one must have 4 times the amount, right? Okay, so my final intensity, I prime, must equal 4 times my original I, which was 1 watt per meter squared. So my intensity of this resulting wave is going to be 4 watt per meter squared. Okay, so this is my resulting intensity from this constructive interference of these 2 waves. Okay, so that is all I have, and I will be shortly posting the lab and homework for this week as well. Hope you have a good week, and happy Halloween!